Founded in 2016, Swarm Technologies bills itself as operating, quote, the world's lowest-cost two-way satellite communications network. The company also claims to have the smallest commercially operational satellites in space. Put these two things together, and they're a unique proposition. Swarm currently has a constellation of 120 tiny smallsats in orbit around the globe, focusing on industries like energy and transportation. Swarm can then provide affordable two-way communication worldwide for a variety of needs. And the kind of network on offer is particularly reliable for tech related to the growing Internet of Things, especially in more remote and rural areas. Unlike Swarm, SpaceX is a far bigger and far better known company. Formed by Elon Musk in 2002, its primary focus is on providing affordable commercial space flights, famously with an eye on Mars in particular. In 2006, SpaceX launched its first rocket, the Falcon 1, and building on its success, the company has continued its progression, launching more rockets and the occasional car into space. Over the course of its run, SpaceX has been awarded contracts from NASA and the U.S. Department of Defense, which has helped to keep their coffers full, all while allowing them to experiment and innovate with otherwise costly technology. Until now, these contracts have largely allowed SpaceX to operate on its own without the need to buy out smaller tech companies, which is one reason why the purchase of Swarm is so interesting. On August 6, 2021, Swarm Technologies, which has an estimated worth of around $85 million, revealed its acquisition by SpaceX in a filing with the Federal Communications Commission. The merger deal had reportedly been signed a few weeks earlier on July 16th. According to Swarm, the company is set to become, quote, a direct, wholly owned subsidiary of SpaceX, while SpaceX says it will, quote, benefit from access to the intellectual property and expertise developed by the Swarm team, as well as from adding this resourceful and effective team to SpaceX. But no further terms and conditions of the deal were released, so how exactly SpaceX and Swarm will fit together isn't yet clear, although clearly smallsats are the order of the day. So what are smallsats, and why are they such a big deal? According to NASA, smallsats, short for small satellite, are spacecraft with a mass less than 180 kilograms, which is just less than 400 pounds. The Pioneer 10 and 11 probes, launched in 1972 and 1973, are considered the forefathers of smallsat tech. Since then, these machines have steadily progressed before an explosion of use and popularity in recent years. NASA breaks down smallsats into different categories, including mini-satellites, which are between 100 and 180 kilograms, microsatellites between 10 and 100 kilograms, and nanosatellites between 1 and 10 kilograms. It's a specific class of nanosatellites, however, called CubeSats that's the primary focus for Swarm. Unlike some other small sats where the dimensions aren't quite so rigid, CubeSats have very clearly defined standards, with every one unit being a 10 by 10 by 10 centimeter cube. These units are then used to designate the size of any given CubeSat. So one that's only 10 times 10 times 10 centimeters is referred to as being 1U. One that's twice that size would be 2U and then 3U and so on. Swarm currently specializes in less than 1U, however, developing quarter-U CubeSats with a mass of only 400 grams. As we've already touched upon, the main benefit of smallsats is their affordability. Due to them being lightweight and small, they can be manufactured quickly and at a fraction of the cost of regular, larger satellites. They're notable for other reasons too, though. While most communications satellites are singular units in geosynchronous orbit, positioned more than 20,000 miles away from Earth, smallsats rely on a network or constellation of several machines all linked up together, and most of them operate in low Earth orbit, and sometimes less than 600 miles in altitude. Satellites at this lower range are generally much more flexible. They're not at all tied to the equator like geostationary satellites are, so they can tilt their plane of orbit to create far more routes for them to travel along. Their closer proximity to Earth also means that they're great for better, clearer, and more high-resolution satellite imaging. And because there are generally more launches available to reach low Earth orbit, assembling smallsats in the sky is relatively easy and fuss-free. However, low Earth orbit isn't without its problems, and communication satellites until now have so often operated in geosynchronous and geostationary orbits for a reason. Geostationary orbit in particular matches the Earth's rotation period, so that the satellite appears as though it's fixed at one point in the sky. This means that the area it's covering never changes, which theoretically reduces outages. By comparison, satellites in low Earth orbit, like smallsats, move very quickly, which could make them harder to track. It's a problem solved, though, so long as there is a large enough network of them. A network of low-orbit smallsats should ensure continuous coverage worldwide with no outages at all. Because now, whenever any satellite goes down, there's always a replacement somewhere else in the sky nearby. So is this what SpaceX hopes to achieve? Providing next-level communications to Earth? Well, sort of. But it's already trying to do that with its own initiative, Starlink. Announced in 2015, Starlink is another constellation of smallsats that SpaceX is developing, aiming to provide broadband internet access to even the most rural areas. According to its website, Starlink satellites operate 60 times closer to Earth than typical communication satellites do, enabling them to better support modern, ultra-fast services such as gaming and video calls. It could be then that SpaceX has simply bought Swarm to broaden its own Starlink network. For now, at least, Swarm appears to be going about its business as usual, with CEO Sarah Spangelo telling TechCrunch that the company is proceeding with its existing plans to expand its CubeSat network to 150 satellites. Upon announcement of the SpaceX deal, there didn't seem to have been any immediate impact on either side. Some onlookers have been quick to point out that the deal could also help SpaceX build a stronger standing with industry regulators, though. So perhaps that's part of the motivation for this move as well. However, it could also be possible that SpaceX has something else hidden up its sleeve. Regardless, and despite SpaceX's long-term plans for Swarm remaining a bit of a mystery, it's becoming increasingly clear that the future of communications belongs to smallsats. This isn't just a one-off development, but a major sign as to how technology in space is changing. Companies like Samsung, Google, and even Coca-Cola are all reportedly investing in smallsats. There are an increasing number of predictions made for the future, generally ranging from 5,000 to 10,000 smallsats launched within the next decade, and very possibly more. Low Earth orbit, then, is about to get extremely busy, and while this is undoubtedly exciting for the future, overcrowding could quickly become a problem. For one, engineers will need to develop ways to prevent collisions between satellites now that there will be so many of them up there. And there's also the issue of the impact they could have on stargazing. Professional and amateur astronomers have already voiced concerns about how the increasing number of smallsats could interfere with night sky viewing. These challenges will likely be overcome, as the sheer cost-effectiveness and seeming reliability of smallsats is so difficult to ignore. It's said that a CubeSat could cost up to 100 times less than a traditional satellite does. So we might say that a sprawling constellation of 100 CubeSats would cost about the same as just one traditional machine. Only the network of CubeSats can offer far wider and more effective coverage. What's more, when even more smallsat networks offering cheaper services pop up, it'll likely force traditional satellite services to lower their prices to compete. So it appears to be a definite win for consumers and a confident step into the future of communication technology.